Welcome back, everybody. Today we're going to cover section 3.4, linear regression. We use linear regression when we have data that is not quite linear, but can best be modeled using a linear model. Here we have a table of data. Let's determine whether or not this data is linear. Data is linear when the rate of change is constant. So to determine whether or not a table of data is linear, what we're going to do is we're going to calculate the rate of change. So let's calculate the rate of change between 0 and 2. The average rate of change from 0 to 2 is the population when the time is 2, that's 14, minus the population at time 0, divided by how much time passed, which is 2 minus 0. Again, average rate of change, this one minus this one, divided by this one minus this one. So here we have 4 over 2, which is 2. The average rate of change from 2 to 4 is 20 minus 14, this one minus this one, divided by 4 minus 2. That's this one minus this one. That's going to be 6 over 2, which is 3. You notice the average rate of change of these two regions is different. Linear data has a constant rate of change, so this is not linear data. The rate of change is different between two different places. So let's plot this data on our calculators. Recall, to plot data, we first need to input it. We do that in the Stat menu. So we click the Stat button here, and then we choose Edit. We put the variable in L1 and the function in L2. The variable in this case comes first, it's time. So we input all of those data points, 0, 2, 4, 6, and 8. And then in L2 we put the function values. The n that matches with t0 is 10. The n that matches with t equals 2 is 14. And so on. 20, 23, and 31. So now that we have the data inputted in our calculator, we want to plot this data. In order to do that, we want to zoom our window to our data. So we're going to go to Zoom, and we're going to go down to the 9th option, which is Zoom Stat. You can also just hit 9 here. And here we have our data plot. Now you notice here, while this data is not linear, it's nearly linear. You could draw a line there and it would almost pass through all those points. So while each individual point may not be exactly on the line, the trend of the data is a constant rate of change. So this is a good opportunity to use linear regression to find a best fit line to this data. To find a linear regression equation using our graphing calculators, after we've entered the data into L1 and L2 and plotted the data, you go to Stat, go over from the Edit menu to Calc, and go down to Linear Regression. The one that matches our course is the 8th option, Linear Regression. So we can go down to the 8th option. That'll give us an a plus bx. You hit Enter. Here we have the x list is L1, that's our variable. Our y list is our function values in L2. And we go down to calculate and hit Enter. When we hit Enter, we get two values. We get an initial value for the line, 9.4, which is the a, and then we get the slope of the equation, which is 2.55. It's shown here what the format is. Y equals a, that's the 9.4, plus bx. So the b is the slope, 2.55. Now let's graph that line on our data. The line that's given is going to be y equals 9.4 plus 2.55x. So I input that line into y equals. I hit y equals 9.4 plus 2.55 times the variable. So I hit the variable button here. Hit the graph button because we're already zoomed to the data that we have. And we can see that this line passes through all of the data. This is the line of best fit. This gives us a pretty good linear model Note, not every point is on the line. This gives us a pretty good model for this situation. Note, if you use linear regression for data that is linear, you'll just get the equation of the line.